Hey you, do you want some code?
Welcome back. Okay, I may have lied a little bit before we can talk about memory leaks. We have to understand the concept of garbage collection. JavaScript is a garbage collected language. That means when JavaScript allocates memory, let's say within a function, we create an object. And that object gets stored somewhere in our memory heap automatically with JavaScript. When we finish calling the function, and let's say we don't need the object anymore, it's going to clean up for us. So JavaScript automatically frees up the memory that we no longer use and will collect our garbage just like this. So only the data that is still useful to us remains. So there is a way we make sure we don't use up all the memory we have available. Because as we know, memory is limited. How nice is that? Now, in garbage collected languages like JavaScript, the garbage collector frees memory on the heap and prevents what we call memory leaks. There is when the memory gets too big until we reach our maximum size, kind of like we did with Stack Overflow. But there is no perfect system. Right, and garbage collection gives us the full sense of security. So we don't have no worry about memory management because this garbage collection is done automatically. There is smart enough to figure out what we need and what we don't. But again, this is actually a big mistake. It gives JavaScript developers the false impression they can choose not to care about memory management. And as you'll see, there's ways to actually make mistake where the garbage collection won't actually free up the memory. Now, that's very, very dangerous, but it's also the reason that programs like C are extremely fast and memory efficient because you control garbage collection, and with that control, you can make it really, really optimized. So, how does garbage collection actually work in JavaScript? Well, it uses something called the mark and sweep algorithm. And this is a great example that shows how it works. Imagine on the left here are variables that we have in our program. And these variables point to different objects. And perhaps an object points to another object and so on and so forth. And as soon as we remove that reference from the object, well, it should get deleted, right? For example, object 5 we don't need anymore because nothing is linking to it. So if we run this, we mark what we need. We sweep what we don't. And that's how garbage collection works. If we look at this through code, we can simply show that in action by using the human over here in our object. And let's change this to var so we can assign it something else. And we'll say that var or human now equals 5. Well, this piece of memory, there is my name, first name and last name is still in the memory heap. But we don't need it anymore. Nothing is referencing that piece of code. Or perhaps this human variable was just inside this function, and once this function is done executing and it's popped off the stack, well, we don't need that variable anymore. So the garbage collector is going to mark and sweep and clean this from memory. And now that we understand how the garbage collector works, we can take advantage of this and show you how memory leaks happen. I'll see you in the next video. Bye bye.